Namaskar, welcome to the course in group theory. And in this course, we are going to discuss permutation groups tonight. Yes, this is the lecture number 12. All right, so certainly I will try my level best to complete this course on YouTube. And I would like to say before this, we have discussed about the definition, properties, examples, about subgroups, groups. Okay, Keller table illustration. In the previous lecture, we have discussed about the Lagrange's theorem as well. But in this class, we are going to discuss about permutation groups because certainly we need a lot of counter examples from this set of group, we can say. Okay, so first of all, we will try to understand the intuition behind the concept. Okay, the motivation behind the concept. So when we used to discuss this topic, then certainly very fundamental things comes into our mind. Yes, that is nothing but a bisective map. Okay, I mean to say a 1-1 onto map or things like that. Certainly we will try to understand. We will also try to understand that what is a group of symmetry. Okay, but I have written something over here. You can see the word grand master questions. What does it mean? It means certainly we will try our level best to understand everything, but with the help of the questions. Some very beautiful but interesting, and you can say hard also. Okay, because this is the very first class on permutation group. So with the help of the question, we will try to understand why this concept come into the picture. Permutation word is not new for us. Okay, and what is the relevance of its meaning, arrangement? Okay, so yes, we are going to discuss all these things in detail. Certainly the questions will come in front of you, but before that I will not forget to start with the intuition. I would also like to say that on this channel I have already completed real analysis. You can check the playlist and certainly that course will help you for sure. Okay, so let's start this session in a proper way. I would also like to say which book is going to be followed in this course. Certainly this page is has taken or we can say some the concepts has been taken from the book Shah and Shankar, Indian writer book for group theory. Okay, you can follow this book. It will certainly help you a lot. So first of all, you can see a triangle over here. Okay, and you can see the vertices A, B, C. So I am just going to make a set A, B, C. And then I want to define a function from ABC to ABC. Okay, so this is the set ABC and let's say it S. And I want to define a function f from S to S. But which kind of function and which kind of rotation is going to be done? Certainly we have taken here equilateral triangle. Okay, so I would like to say when we have a function from this set ABC to the set ABC, then you can observe one thing, that when this triangle is going to rotate by 60 degrees, so if we will take the function as rotation, then we can see this A is going to B. Okay, this A is going to B, and this B is going to C, and this C is going to A, and this is how the permutation is going to happen. Okay, so certainly I would like to say all the bisective map, if we want to define the permutation, then this is a 1-1 onto 1-1 map from this set S onto itself. Okay, So here you can see, being a function, each and every element of this set S has unique element in S. So how many possibilities, how many bisective mappings are there? So certainly you can say factorial 3, because this ABC can be rearranged in factorial 3 ways. So there will be factorial 3 numbers of bijective functions from F to F. And the collection of all those 3 functions is going to make a group. And that group is called symmetric group. Okay. So certainly we are going to discuss all these things in a proper way. So if you have 3 elements, then there will be 6 elements. I would like to say factorial 3 number of elements in the group, in the permutation group, you can say. Okay, and I am going to discuss all these things in detail. Don't worry, certainly the representations and everything will be discussed in a very beautiful manner with the help of the questions. Okay, so but think, if you will have n number of elements, then what the thing is going to happen? If the set A has n number of elements, then how many elements will be there in the permutation group? Certainly there will be factorial n number of elements in that permutation group. Why? What is the reason behind that? Because these elements can be rearranged in factorial n ways, and every arrangement will give you the member of that permutation group. And that's why you will say factorial n number of elements will be there in the permutation group. And there are 2 ways to represent a permutation group. For example, you can see representation over here. You can see this is a 2-row representation. We used to write the elements of A over here, and we used to write their image over here for sure. Okay, so this is a 2-row representation. And there is also a very interesting and very useful way to represent a permutation group, and that is called a cycle notation. And the very first question of this evening is completely based on the representation of permutations. For example, before coming to that question, I would like to tell you that here is A with 5 elements, where 1 is going to 3, 2 is going to 5, 3 is going to 2, 4 is going to 4 itself, and 5 is going to 1. Okay, so here you can see how we are going to represent it. 1 is going to 3, so 1, 3, 2 is going to 5, 3 is going to 2, and 4 is at 4 only, so you can see 4 with 4, and 5 is going to 1. So this is a 2-row representation. But how shall we represent it in cycle notation? Certainly we are going to discuss it. And very first question of this evening is here in front of you. I would like to welcome some of the people who are over here. Ashish Tiwari ji, Nitu Kumari ji, Muhammad Ashim ji. So you all are welcome over here. And this question is waiting for your response. If anyone is there, then certainly I would like to see the response from your side. Otherwise, certainly I am here to discuss it. If anybody is there, then please let me know. Permutation from S4 is written 1, 2, 3, 4 in this manner. And you have 4 options. This is a concept building question. So you have to be a bit careful to say the things, because more than 1 options may be true. Asim ji, a very, very good evening. Ashish Tiwari ji, welcome. Nitu, you are also welcome over here. So certainly you may try, because with the help of the question, certainly you may revise the things. You will get the confidence as well. What is the way to say the things quickly? Certainly it may be helpful. I'm waiting for your response, Ashish ji, Muhammad Asim ji. I think certainly you may be there, and will certainly try to give the answer. Otherwise, I will discuss it for sure. You may write pass also. Because with the help of the question, we will be able to discuss everything in a very beautiful manner. Understanding will be developed for sure. So here is what 1, 2, 3, 4. So in option D, a 2-row representation is here. So certainly we can try to understand that what is the relation between a cycle notation and 2-row representation. And this time Ashish Tiwari ji has given the answer, but Ashish ji, more than 2 options are true. Okay, you are saying that B and D options are right. Shubham ji, you are also welcome over here. So first of all, you can see what 1 is going to 2, 2 is going to 3, 3 is going to 4, and 4 is going to 1. Okay, so yes, the cycle notation 1 is going to 2, 2 is going to 3, 3 is going to 4, and 4 is going to 1. This is the cycle notation. So what is the problem with A, Ashish ji? Its order is 4 as well. Yes, we'll discuss. Shivani is saying D, but Shivani, more than 1 options are right. Certainly you are saying the right thing, but option D is true for sure, because the 2-row representation of this cyclic notation is certainly this, because from here you can also see 1 is going to 2, 2 is going to 3, 3 is going to 4, and 4 is going to 1. So this is a 2-row representation. But I would like to say the answer that every 4 options are correct. People will say, how? Certainly all these 4 options are absolutely right. Because what is the way? What is the way? Thank you very much for your words, Mr. HJ. We really appreciate all your words, and it gives us a motivation for sure. So thank you very much. So first of all, we will try to understand, because if you know the concept, then certainly you can give the answer without using the pen also. So you will say how you can say. So what is the way to find, if f is given, then what is the way to find f squared? Isn't it? So for f square, first of all, this is certainly the 2-row representation of this cycle notation, undoubtedly. 1, 2, 3, 4, so 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes to 1, so this is a 2-row representation. What about f squared? So for f square, what we used to do, we skip 1 element. Right? What is the way? We skip 1 element. So for f square, from 1 we are coming to 3. So 1, 3. And once again, what the thing? For 2, we have to skip this 3 and we will come over here at 4. So your f square will be what? 1, 3, 2, 4. If anybody has any doubt, then certainly they are welcome to speak. So that's why your f3 is what? 1, 3, 2, 4. Because if you have to find f square, then you have to skip just 1 element. So this 1 will come over here at 3. This 2 will come over here at 4. This 4 will come here at 3, at 2. And this 3 will come over here at 1. So 1 और 3 पे क्या होगा? ठीक है? Because 1 is coming to 3 and 3 is coming to 1, because we have to find f square, so we are just going to skip just 1 element. This is the trick, that you have to skip just 1 element when you are going to find f square. And what is the trick for fq? You have to skip 2 elements, isn't it? For example, if you are over here at 1, then you have to skip this 2 and 3, and thereafter you will reach at 4. If you are here at 2, then you have to skip this 3 and 4, and you are here at what? I would like to say, if you are over here at 4, then you have to skip at 1 and 2, and then you will reach at 3. If you are here at 3, then you have to skip this 4 and 1, and then you will reach at 2. So this is how we used to write the things. Okay? How this f3 has obtained, once again I am going to repeat within seconds, that for example, if we are over here at 1, then as we have to find f3, so we have to skip this 2 and 3 and we will be over here at 4. Once again at 4 we have to skip this 1 and 2 and we will reach at 3. And if we are here at 3, then we have to skip this 4 and 1 and we will be here at 2. So this is how we are going to obtain this f cube. But why we are saying that this is the order of f is equals to 4? What is the reason behind this? The reason behind this is what? Because if you have to find f4, then in that case you have to skip 3 elements. For example, if you are over here at 1, then you have to skip this 2, 3 and 4 and you are going to reach at 1. If you have to go from 2, then you have to skip this 3, 4 and 1 and once again you are coming at 2 only. So every element comes to itself in the case of f4. So in the case of f4 you are going to get the identity only, because if you are over here at 3, then you have to skip these 3 elements 4, 1, 2 and you are coming at 3. Okay, so in this way you are going to get what? The f4 is nothing but the identity permutation, and you will not hesitate to say that this 4 is the least positive integer such that f to the power 4 is equals to identity, and it will allow you to say that the order of f is nothing but 4. So that's why all the 4 options were absolutely right. Now we are coming for the next question. Once again, one more chance to give the right answer. Will you be able to do it? It's very interesting because this is a grand master question series. Okay, so you should try your level best to give the right answer, because with the help of the questions we are trying to understand the concepts, understand group theory in a very beautiful manner. Okay, so what is the thing over here? F is equals to 1, 2, 3 and here 4, 5. So more than one options are correct, but you should be very careful to say anything. You should be very careful to say anything. You must be very careful to say anything. Okay? All right, what would you like to say? What would you like to say? How shall you get f squared? This time Ashish Tiwari ji is very quick, but Ashish ji, you have to be careful because it's a 4.75 marks question. It's a 4.75 type question. Either you will get 4.75 or you are going to get 0. I am still waiting for the very first correct answer up. Okay, I have not gotten any correct answer up till now. Okay. आ गए लगता है मुझे कि मैं आ गए हैं. आई थिंक वी आर हेयर, है ना? एम आई देयर? यस. चलो, कहाँ गया रे भैया? आहा, yes. Okay, so the connection is restored, and yes, the concept is also. So here we have what? F. Here you can see f as the product of disjoint cycle, a cycle of length 3, and here is a cycle of length 2. Okay. So yes, this f has represented like this, and then you have to find f square. So I am waiting for your response or response. Okay. I think I am live and everything is fine now. Okay. Just want to know your response. Are we live over here? I think everything is fine. Yes. Yes, we are live now. And the question is there in front of you. So one must try this question. Otherwise, certainly I will solve it for sure. Yes. I think some response may come for this question, and thereafter we will try to understand then that how these things are going to happen. What is the way? Because here you can see two cycles are over here. One cycle says 1 is going to 2, 2 is going to 3, and this 3 is going to 1. Another cycle says that this 4 is going to 5, and this 5 is going to 4. So we have two cycles over here. And in this case, you have to find f square. So what would you like to say? What is the right answer according to you? If anybody is there, then certainly they should try their level best. Come on. F is given. Okay. 1, 2, 3 is one cycle. You can see over here. Another cycle is 4, 5. 4 is going to 5. 5 is going to 4. Okay. And you have to find f square. So what is the way? And this time Ashish Tiwari is there and he is absolutely right this time. Yes, Ashish ji, you are absolutely right. Because if you want to find this f square, then in this case, this you have to skip just one element. So 1 will go to 3. And for 3, you have to skip this 1. So you will go to 2 once again. And this 2 will come to 1 once again. Okay. So this is 1, 3, 2. But some people will say that where is this 4, 5? So I would like to say, if you will skip one element, then from 4, you have to skip this 5 and you are coming to 4 itself. So it's identity. And identities are not going to be written as the cycle notation. Sometimes you may write 4 or you may write 5 or you may write nothing. It does not matter because that is the identity permutation only. So that's why this B is absolutely right. What about F cube? So for this F cube, you have to skip 2 elements always. So from 1, you have to skip this 2 and 3, then you will come to 1 only. From 2, you have to skip this 3 and 1 and you are coming to 2 only. And from 3, you have to skip this 1 and 2 and you are coming to 3 only. So every element comes to itself and therefore this 1, 2, 3 will give you the identity. But what about this 4, 5? Because this notation, this cycle will give you something itself. I mean to say, from 4, you have to skip 2 elements. So you are going to skip this 5 and 4. So this 4 will come to 5 once again and this 5 will come to 4 once again. So f cube is equals to 4. Sorry, 4 comma 5. In the same manner, if you will find f4, then what are the things you are going to get? I'm just going to ask, is your f4 1, 2, 3? Please do comment. For this permutation only, I'm just going to ask, if your f is 1, 2, 3, 4, 5, then is your f4 1, 2, 3? What would you like to say? Is somebody there to say yes or no? What will be f4? Is it 1, 2, 3? If your f is given 1, 2, 3 and 4, 5, so what would you like to say? And this time Ashish Tiwari ji is saying yes. Because what the thing is going to happen? This time we have two things. 1 is going to 2, 2 is going to 3, and 3 is going to 1. 4 is going to 5, and 5 is going to 4. This kind of things is going to happen according to this given f. So in this time you have to find f4, so you have to skip 3 elements always. Okay, so from here what the thing is going to happen, this 1, so you have to skip this 3 elements, so 1 2 3. Okay, so you will come to 2, and from 2 you have to skip 3 elements, this 3 1 and 2, so once again you will come to 3, so 3 is over here. Okay, and what about this 4 5? Because if you are here at 4, then you have to skip 3 elements, so 1 2 3, once again you are coming to 4, so it will become identity. So here your f4 is what, 1 2 3. And what about f5? Certainly your f5 will be 1 3 2 and 4 5. Are you agree with this? Shubhamji, you are also right. So your f5 will be 1 3 2 4 5. Are you agree with this? Your f5 will be 1 3 2 4 5. Are you agree with this? And your f6 will be what? Identity. Okay, so that's why the order of f is what? 6. So all these B, C, D are the right answer. Okay, Ashish ji, Shubham ji, Nitu, and everyone who is watching this lecture right now or will watch it recorded. Now the next question has also its beauty and it's really interesting. So what the f is given? 1 2 3 1 4 5. It is the product of two permutations, you can see. 1 2 3 and 1 4 5 is there. So it's a product of two permutations, and then you have to get the conclusion. You have to be very careful to say anything. Okay, f99, things like this is over here. f99 is equals to f inverse, f5 is identity, f100 is I. What would you like to say? f99 is this one, 3 2 5 4 1. What is the answer? More than one options are correct. Come on. More than one options are correct. What would you like to say? Certainly this has been taken from S5, so everybody will try to write it in a two-row representation for simplicity. I am helping you to write it now. Okay, so first of all, when you will write this cycle 1 2 3, 1 goes to 2, 2 goes to 3, and this 3 goes to 1. So certainly 1 goes to 2, 2 goes to 3, and this 3 goes to 1, and nothing is written in this cycle. So certainly 4 remains constant, 5 remains constant. So this is the two-row representation of the very first cycle. What about the another one? Okay, so here you can see 1 2 3 4 5. According to this cycle, 1 goes to 4. Okay, and 2 is not going anywhere, so we are just going to write 2 is constant, 2 will remain constant. 3 is not there in this cycle, so certainly 3 will remain constant. This 4 is going at 5, and this 5 is coming at 1. So this is how you can write this cycle into two-row representation, this cycle into two-row representation, and nobody can forget the product of two permutation. Once again we are going to write 1 2 3 4 and 5. So this 5 is coming to 1, and this 1 is coming to where? Certainly, what can you see? This 5 is coming to 1. Okay, and this 1 is coming to where? What would you like to say? Okay, am I right? This 5 is coming to 1, this 1 is coming to 4, and this 4 is coming to 4. Right? So this product will be like this. And finally in cycle notation it will be what? You will write it as 1, 4, 5. 1 is coming to 4. Okay, 4 is coming to 5. 5 is coming to 2 and 2 is coming to 3. So this product can be written as this cycle 1, 4, 5, 2, 3. Isn't it fine? The given cycle can be written as 1, 4, 5, 2, 3. This is how we can write. Okay, this is how we can write. And so here first of all we will try to justify, is this F5 is equals to identity? So you also know after skipping these 4 elements we are coming to 1. After skipping these 4 elements we are coming to 4 itself. So we are just going to make a cycle notation. 1 goes to 4, 4 goes to 5, 5 goes to where? Oh, just a second. 5 goes to 2, 2 goes to 3, and this 3 goes to 1. So the option was what? F5 is equals to identity. So you can easily understand that after skipping these 4 elements we are coming to 1. So certainly after skipping these 4 elements we are coming to 4. After skipping these 4 elements we are coming to 5. So after skipping n minus 1 number of elements we are coming to the same element. It means certainly n is the order of this permutation. Yes. According to this you can say 4 is coming to 1, 1 is coming to 2. So I think one representation can be written in more than one way, Ashish ji. Isn't it? Okay. So we can check it. Okay, but the counterclockwise way cannot be disturbed. Okay, Ashish ji. So you can certainly check the calculation. Okay. So here what the thing is there, F5 will be I. So this is a matter of calculation, one can check it easily. Okay, we can represent a permutation in more than one way, but the counterclockwise sense, the sense should not be changed. Okay, so it's a matter of calculation. Concept wise we can see it easily that after skipping 4 elements we are going to get the same. It means F5 is equals to I. So if F5 is I, then this F100 can be written as how? F5 to the power what? Certainly we can write F5 to the power 20. F5 is I, so I to the power 20 is once again I. So F100 will be every multiple of 5. F to the power every multiple of 5. Take it. So F100 will be I. Yes, you should check that once. Okay. And thereafter you can see what? If you have 1, 4, 5, 2, 3, then what about the inverse? What about the inverse? Because F100 is I, and if you are going to multiply both sides with F inverse, then F99 will be equals to F inverse, because F100 is equals to I, and if you are going to multiply both sides with F inverse, then F100 into F inverse is equals to I into F inverse. So it will become F to the power 99 is equals to F inverse. So A is right, B is right, C is right. And F inverse. So if your F is 1, 4, 5, 2, 3, then certainly its inverse will be what? 3, 2, 5, 4, 1. 3, 2, 5, 4, 1. So D option is also right. So what are the things I would like to say? Just check the product. You should write this 2-row representation in terms of matrix representation. You should check the calculation, but the concept is very clear that if you are going to skip 4 elements and then you are going to get the repetition, then certainly the order will be 5. So F5 will be identity. So every multiple of 5 power of f will be identity as well. If you have f100 is equals to I, then you will multiply both sides with f inverse. Then certainly you will get f99 is equals to f inverse. And certainly f99 is nothing but f inverse. So we will just write the inverse of the permutation, and finally we will get our answer. Okay. So these were a few questions. Now this question is over here because certainly I want to tell you something that should be known by everyone, and I think many of you know it already, that if your f is equals to what? A1, A2, A3, okay, and by doing so AR belongs to Sn, R is less than or equal to N, then order of f is what? Order of f is equals to what? R. I mean to say, what the thing is there? If you have, it means the order of the cycle. Okay? Order of the cycle, because if you have R number of elements in a cycle, then its order will be what? R. But sometimes we used to write the permutation as the product of disjoint cycles, right? And in that case, we used to find the order in terms of LCM. So what is the result? Once again, I would like to say Ashish Tiwari ji is saying C. Okay, this option C is over here, not 10. And certainly this F is what? If you have a permutation F written as F1 into F2, and this belongs to Sn, where these F1 and F2 are disjoint. Disjoint means what? Nothing is common. Okay. Then what the thing is going to happen? The order of F will be equals to the LCM of order of F1, comma, order of F2. Okay. If this F is going to be written as the product of F1 and F2 and it has been taken from Sn, then order of F is what? This is a very nice result. It will be equals to LCM of order of F1 into order of, comma, order of F2. कहने का मतलब order of F1 और order of F2 के LCM के बराबर आपका order of F होगा if F is written as the product, I mean to say product of F1 and F2, where F1 and F2 are disjoint. So we can see one thing over here, that certainly we can write it as disjoint cycles, isn't it? Because you can see this 1 is going to 3 and this 3 is going to 4 and this 4 is going to 1. So this makes one cycle. What is that? 1, 3, 4. Once again, this 2 is going to 5, this 5 is going to 6, 5 is going to, this 2 is going to 5, and this 5 is going to 2, so it's closed. Once again, this 6 is going to 7, no, 6 is going to 6 only, so it's fixed. But here you can see this 7 is going to 8, this 8 is going to 9, this 9 is going to 10, and this 10 is going to 7. So here you can see what? 7, 8, 9, 10. So you have 3 elements in this cycle, 2 elements in this cycle, 4 elements in this cycle. So finally the order of this F will be what? LCM of 3, 2, and 4. Because these are the disjoint cycles. Okay, so order of this F has been written as disjoint cycles. Therefore, the order of F will be the LCM, least common multiple of 3, 2, and 4, which is nothing but 12. And that's why this option C is absolutely right. So thank you very much, Shubham ji, Ashish Tiwari ji, and everyone for watching it now. And if you will come I mean to say regularly, then certainly I will also come regularly. Okay, and this is a HW question. Okay, so this is sigma, this is tau, and then you have to say about the product. You know it already. So certainly you should write this question, and from this question only we are going to start the session tomorrow at 8:30 p.m. We will try to come continuously. If you will be regular, then I will be regular also, because your presence is our motivation. Okay, and certainly I will try my level best to come up with very nice questions for sure. I would also like to say that on this channel I have already completed real analysis, and I am trying to complete algebra and certainly linear algebra, because I have already promised about it. But sometimes I don't come because you don't come as well. If you will come regularly, then I will try my level best to come regularly. And I have given the name of this series as Grand Master Questions, because certainly with the help of the questions we will try to come, we will try to discuss, and we will try to do something better for sure. So together we will make it, and we'll try to come tomorrow also. That will be the live class 13, and we'll see you tomorrow. Till then, take care. Bye bye. Thank you very much, Ashish Tiwari ji, Nitu Kumari, Shubham ji, and everyone who is watching this lecture right now. We'll see you tomorrow. Till then, take care. Bye bye. Good night.